For this past 4th of July, you might have remembered planning around these ridiculous temperatures, up to 110 degrees in DC. That's insane, right? Or maybe you've gone on a jog and you've decided that it's really hot out, so I'm going to wear a white t-shirt instead of a black t-shirt because I know I can stay cooler. This all has to do with heat, and that's what we're going to talk about for the next 5 minutes. So I'm going to put some science to it and hope I make Bill Nye proud. Today I will be explaining the negative impacts of the urban heat island effect, explain the successful solution of albedo restoration, and present you, the audience, with a cool opportunity to keep UMD cool. Okay, so the urban heat island effect is when an urban settlement is developed in an area that might have been grass, lakes, trees before. And what happens is that these dark materials that are used for construction do a great job of absorbing heat, whereas before that energy was being converted in photosynthesis or reflected back into the atmosphere. So if you can see this Manhattan, you can see Central Park is this cool zone because of all the plants and water. This has to do with albedo, which is the proportion of light that is reflected or absorbed. So 0 is black and is completely absorbed, or 1 is 100% and is being reflected back into the atmosphere. So we're going to go to UC Berkeley's lab webpage updated in 2018 on urban heat island, which explains that pavement can make up to 60% of an urban area, and that of that 60%, 80% of it can be 80% of the heat that hits it is absorbed. So we're starting to heat up around here. Then we go to the EPA, and they explain on their webpage on heat island effects, updated in 2017, that there's this increased use of energy because what happens is people want to keep cool, right? So the research shows that electricity demand for cooling increases 1.5 to 2% for every 1 degree Fahrenheit increase in air temperatures. This is because when our buildings start to warm up by absorbing all of this heat, we have to use more air conditioning to offset. Where does this electricity come from? Factories that emit sulfur dioxide, nitrogen oxides, and mercury, to name a few. So we go back to UC Berkeley's lab webpage, and they talk about this decreased air quality, pollution, smog, you name it. Beyond that, there's this increased chance of illness. Beyond just heat stroke, there's a chance for people with respiratory inflammation to suffer even more. But don't worry guys, I have a cool solution. White roofs. On the sunniest days, a typical roof can reach upwards of 150 degrees Fahrenheit, whereas a cool roof can stay in the 50-degree range, according to the U.S. Department of Energy site last updated in 2018. What happens is we take these dark materials and we put a solar reflective paint. This is practical. It's already being done, especially in the southern areas of the United States. And it's desirable because we already have to restore roofs. All they have to do is pay a little extra for that cool seal, and they end up saving a lot of money on their energy costs. This also can be done with green roofs because the plant material does such a great job of absorbing it for photosynthesis or reflecting it, as talked about before. Like I said, everyone's saving money here in the long run. Southern California has been the leader in albedo restoration. This is in Los Angeles, in Canoga Park. The residents of Canoga Park were astonished, even thrilled to see black asphalt turn a light shade of gray within 30 minutes, according to the Los Angeles Daily News in late August of 2017. We're seeing quick, fast results, and residents are happy about this. It's all happening within one day. It seems like a win-win situation. So let's zoom back into our area, Maryland. This is that same dreadful July heat wave. And then let's zoom more into UMD's campus. So we see a lot of dark areas. We have parking lots, we have buildings, but then you may see that there's some white roofs. I was curious, because I didn't know that UMD had been maybe doing something about this. So I go to research, and I find facilities master plan that goes through 2020. Through these hundreds of pages of documents, I come across this one line that basically says they are choosing to transform these surfaces over time to lighter colors to help offset this urban heat island effect. Better yet, residential facilities is doing the same thing. Install solar reflective roof surface to reduce summer heat gain and lowers air conditioning energy use. This means our campus is aware of it and they're already doing something. Well, you may have remembered I said you could do something about this. See, there's this amazing sustainability fund that funds students to make a difference on campus. What about education? We don't know about these cool rules. I had to research for like an hour to find those two documents. And beyond that, what about these huge parking lots that are absorbing so much heat that there's no plan to do anything about? They already know that urban heat island effect is real. This is Cumberland, and they were funded by the Sustainability Fund in 2008 to install a green roof. So I hope today you learned a little bit about the urban heat island effect, and that you took something away from these government agencies, and you learned the science behind it. And if anything, do it for the children. Look at that dark surface. If it gets too hot out, these students can't go outside to play. Thank you.